Hello everybody, welcome back. Today we're going to be starting 5.2, properties of functions. The focus of our lesson is going to be to develop the concept of what a function actually is. Okay, so you may recall from your earlier grades of an input-output machine. You may remember this. You may not, and that's fine. Okay, so if I input the number 1, what's the output going to be? Well, if I input 1 and I multiply it by 2, then that will be 2. And if I add 3 to that, 2 plus 3 is 5. There's the output. Let's try number 2. Put number 2 in, boom, multiply it by 2 gives us 4. Add 3 to 4, and we get 7. And this can go in reverse as well. So if you know the output, you can find the input, just going in reverse order, right? Just inverse operation, same idea. So if we have 9, we're going to subtract 3 from it, boom. And instead of doing multiplying by 2, we divide by 2. So we'd have 6 divided by 2 is 3. Input's 3. And so on. The first set of elements of a relation is called the domain. And this is going to be related directly to the x values or the horizontal values. The set of related second elements of a relation is called the range. This is going to be directly related to the y values or the vertical values. Okay, so a function is a little bit different than a relationship, where it's a special type of relation because of each element in the domain associated with exactly one element in the range. So this is a definition. I remember this from my high school teacher. For every value of x, there's only one value of y. Okay, just remember that, and it'll stick with you. And you'll always understand what a function is. For every value of x, there's only one value for y. Okay, just remember that. Here are some different ways to relate vehicles and the number of wheels each has. So this relation associates a number with a vehicle with that number of wheels. So 1 is the number of wheels on a unicycle. 2 is the number of wheels on a bicycle and a motorcycle. 3 is the number of wheels on a tricycle, and 4 are the number of wheels on a car. The relationship associates a vehicle with the number of wheels in the second column. So a bicycle has 2 wheels. A car has 4 wheels. A motorcycle has 2 wheels. A tricycle has 3 wheels. A unicycle has 1 wheel. So which one represents a function? This is what we're trying to develop here. So remember, for 1, this would be your x value. This would be your y value. In this case, this would be your x value. This would be your y value. This would be your domain. This is your range. This is the domain. This is the range. Okay? So we have to think of it in terms of this and that. Okay? This first diagram does not represent a function because there is one element in the first set that associates with 2 elements in the second. That is, there are 2 arrows from 2 in the first set. So for every value of x, there's only one value of y, and that's not true because the bicycle and the motorcycle both have 2 wheels. So 1 unicycle, 2 bicycle, 2 motorcycle. So this is what's causing this not to be a function. The set of order pairs does not represent a function because there's 2 order pairs have the same first element. Okay? In the second set, we have the diagram represents a function because each element in the first set associates with exactly one element in the second set. That is, there's only one arrow from each element in the first set. So you'll notice here we only have one arrow going to each, right? Okay? So for each value of x, there's only one value for y. That's not true here. For each value of x, there's only one value here for y. Okay? Now I know the 2 showing up twice, but that's okay. The domain of the first set of elements, 1, 2, 3, and 4. The domain of the first set of elements is a unicycle, bicycle, motorcycle, tricycle, car. The range is the second set of elements, unicycle, bicycle, motorcycle, tricycle, car, and the range is a set of the associated values 1, 2, 3, and 4. Okay, so I think this will be a little more easy to understand once we get into some values later on in the chapter. Okay, but I just want you to get that understanding. Let's look at the first example. First example says we're going to be identifying functions. For each relation below, determine whether the relation is a function. Justify the answer. Identify the domain and range of each relation that is a function. Okay? The first one, it says a relation is that associates given shapes with the number of right angles in the shape. So a right triangle, one right angle. An acute triangle, 0 right angles. A square has 4 right angles. A rectangle also has 4 right angles. And a regular hexagon has 0 right angles. Because you know a regular hexagon, since it has 6 sides, each one would be a different value there. And we'll talk about those. We do that in grade 11 actually, but there are no right angles in a regular hexagon. So let's look deeper into this, remembering what the definition of a function is. So we want to first check to see if any ordered pairs have the same first element. So right triangle, acute triangle, square, rectangle, regular hexagon. So each ordered pair has a different first element. So for every first element, there's exactly one second element. So this relation is indeed a function. Now, there could be 2 y values. That's fine, right? But for each value of x, there's only one value for y. So if we had, let's say, 2 squares, right? And we were talking about something different, and the numbers were different for the y values, or the second set of values, then that would not be a relation. We'll see that in another example. So the domain, remember, is your first set of values in the order pair. So right triangle, acute triangle, square, rectangle, regular hexagon. And the second, you don't need to repeat 0, 0 twice, 4, 0 twice. Normally we order these from least to greatest. They don't have to be ordered as given. So it's 0, 1, and 4. Okay. Next we have we have a given arrow diagram, and we're going to determine whether this is a function or not. Okay. So in the B part, we have to all we have to do is check to see if any element in the first set associates with more than 1 in the second element. You can clearly see that 1 is associated with -1 and +1. We can see that 4 is clearly associated with -2 and 2. So there's 2 examples of why this is not a function. My apologies for the PA. So you can try the check your understanding. There's a couple of questions there. The answers are at the bottom. But you're going to determine whether the relation is a function, justify your answer, identify the domain and range of each. Okay? So remember, for every value of x, there's only one value for y. Or for every value in the first set, there's only one value in the second set. Okay? Next, we're going to look at how to describe functions in example 2. So in the workplace, a person's gross pay, P in dollars, often depends on the number of hours worked. So gross pay is basically multiply. One way to do it, and we're going to look at this later on when we do the financial section in Chapter 8. Gross pay is how much you make. So basically, you multiply the number of hours you work by the number like what your rate of pay is. So if you make $15 an hour and you work 4 hours, 15 multiplied by 4 is 60. So you earn $60. Okay. So here we're going to look at some of what's called independent and dependent variable. So in this particular case, and usually we'll put a variable on that. So a person's gross pay, and they're just using P as pay in dollars. Often depends on the number of hours worked. So number of hours worked, we usually use N for number of hours, or H, obviously we're working with hours. So we say P is a dependent variable since the number of hours worked. H does not depend on gross pay, right? So your pay depends on your hours of work. So time is almost always, I'm not going to say 100% of the time, but 99.9% of the time, anything involved with time is going to be your independent variable. Okay? So the hours worked is going to be your X values or your independent variable, and your second column, your gross pay, is dependent variable because gross pay depends on the number of hours worked. And domain, remember, is going to be your X values, and your range is going to be your Y values, or your domain goes along the horizontal axis. Once we start graphing these, you'll get a better understanding of that. And your range goes on the vertical, or the Y values. Okay? So let's take that information and we'll look at the describing function value. And there's a check your understanding goes side by side. I'll let you guys work on that. But let's look at why this why is this relation also a function, right? So remember, a function is a special type of relation. So the table shows the masses, m in grams, of different numbers of identical marbles. So right here we can see that the number of marbles, we don't have anything repeating twice, so it is a function. So to show this in words, for each number in the first column, there's only one number in the second column, right? So if we have 1 here, we'd have another 1 here somewhere, or there would be 2 in here, but usually it would be repeated in the first column. And obviously it's 1 through 6, it's not repeated, so this is a function. Identify the independent variable and the dependent variable. Justify the choices for these. So based on my understanding of the situation, the mass of the marble M depends on the number of marbles, right? So if you have 3 marbles, that mass is going to depend on that number, right? So M is the dependent variable, the mass, and N is the independent, the number of marbles, right? I can see how you would think it goes either way, but like I said, once we get the hang of this, it'll become a little more familiar, I would say. Okay. Next, we have the domain and range. So we're going to write the domain and range next. So looking up here, the domain is going to be your independent, which is the number of marbles. So obviously these are natural numbers. They can't have 0 or negatives. So it's just your natural numbers or your counting numbers. So 1, 2, 3, 4, 5, 6, and so on. So again, we'll notice that I put comma and the 3 dots. I mean, it'll continue on forever, right? Okay, depending on how many marbles you have. And the range are the corresponding mass values. So 1.27, 2.54, 3.81, and so on. Okay, so basically what you're doing is you're adding on 1.27 each time, right? So 1.27 times 2, or adding 1.27 is 2.54, so and so on. Again, they can continue on. Okay, so that's going to be it for this video. That's in the next video, what we'll do is we'll continue on, and we'll look at example 3, and then we'll finish up the chapter. All right, so thank you for everybody for watching, and we'll talk again soon.